Okay, in this video, we're going to go over day 1 of 2.5. And so we're going to continue working on optimization, and that's pretty much what we were doing in 2.4. We just didn't speak about it in that way. So, as I say in this overview, you're going to use calculus to optimize a solution. In these types of problems, some quantity must be either minimized or maximized. Okay, so those are going to be our two choices. It's either going to be minimized or maximized. You will have the same approach whether you're looking for a max or a min, so do not be confused about this. Make sure you are actually answering the question, because not doing so is a very common mistake. Use your curve sketching techniques from 2.3 and 2.4, and that means we're revisiting first and second derivatives, first and second derivative tests, and the concluding statement, and you're going to be able to give me a graph. So I'm going to allow you to use calculators in this section, but just because you can use them doesn't mean you have to use them. Okay, so here's our function, and our job is to find the minimum value of the function. That is a y value. Okay, minimum value of a function is the y value. You are very used to finding only the x's and talking about them. Okay, so first thing, because you want to find the minimum value of the function, and this is a cubic, we're going to do that by taking the first derivative, setting it equal to 0, and finding the possible extremums. Okay, so here we go. F prime of x, looking at that function, it's going to be 3x squared minus, okay, so now the 2's come down and cancel, minus 15x plus 12. Don't forget the plus 12. Many of you will drop off the last term because you're eager to get to work. So let's don't do that. So first thing I'm going to do, because I know I'm going to set this equal to 0, is recognize I have to do some factoring. Now when you factor, you can go ahead and do hard factoring, which means that you are going to include this 3, or what you can do is first factor out the 3. That would be my recommendation. Okay, so I factor out a 3 there, a 3 there, and a 3 there. Now you have a very easy factoring problem. Okay, so what multiplies to 4 and adds to negative 5? So that's going to be x minus 4 and x minus 1. So it's 4 and 1 is what I'm looking for. Okay, I'm going to move this up in just a second, so let me just stop the video for a minute. Alright, so I've moved this to the next page. So what I can see right now, if I set this factored function equal to 0, my critical values will be positive 4 and positive 1. Okay, there's no x involved with 3, so I'm not getting another critical value there. So my critical values, which are x values, are x equals 1 and x equals 4. Alright, so now let's go ahead and we'll do a first derivative test. So here's my sign chart. I put this in order as you would on a number line. Up here I'm going to evaluate my first derivative. I pick a number to the left of 1. 0 is the best. So putting 0 in your function gives me, putting a 0 in here, it's going to give me a negative. Putting a 0 in here gives me a negative. A negative times a negative is a positive, and a positive times 3 is still a positive. So here my function is positive. Okay, now we're going to test the area between 1 and 4. So let's use, let's see, maybe we'll use like 2. So plugging a 2 in here gives me 2 minus 4, which is a negative. Plugging a 2 in here gives me a positive. A negative times a positive times 3 is a negative. So right here I get a negative. Okay, we're going to change colors again, and let's check to the right of 4. So plugging in a 5 here gives me a positive. Plugging in a 5 here gives me a positive. Positive times 3 is a positive, and my value is positive here. So we know to do our little sketch of what the function would look like. If the slope is positive here, and negative here, and 0 here, and then positive here, this is what it looks like. So we are trying to find the minimum value. So first thing I'm going to do is write a statement, because I've done a first derivative sign chart. So my statement is, at the CV of 1, okay, the slope changes positive to negative. That leads to a max. Okay, and then at the CV of 4, the slope changes negative to positive. That yields a min. Now, if we were to stop here, we would not be done. So they are asking me to find the value that minimizes the function. Oh, and by the way, the constraint was that x had to be greater than or equal to 0. I have satisfied that constraint just by virtue of the fact that the critical values were already greater than or equal to 0. So I have no more worries about that constraint. Okay, so how do we get our function value? What we want to do is to get the function value. So the function value at the minimum means to evaluate the original function at 4. And if you do that, you're going to see that you're going to get a 12. So I'll leave that for you to verify. But it is indeed 12, and 12 is the minimum value of the function. Now, I've only done a first derivative test here. You can do a first derivative or a second derivative test. If they don't require you to do both, you can do either or. In this situation, I did a first derivative test. Had I done a second derivative test, what would have happened was that I would test right on top of the critical values. So I'm going to do that on the next page just for completion. Okay, so now I'm going to go and use some of the tidbits I have on this page to go and do the second derivative test. So you can see right here on the top, I have the first derivative test, and the statement was on the previous page, so I'm not going to redo the statement here. Now let's go ahead and take your unfactored first derivative and get the second derivative. So that's going to be 6x minus 15. So what's happening now is I'm putting 1 and 4, my critical values, on my sign chart. Here is my second derivative test. Here it comes. Okay, if I plug 1, and I'll change colors, if I plug 1 into here, I'm going to get 6 minus 15, which is a negative, and if I have a negative, it is concave down, so I have a max. That affirms what the first derivative test told me. Now let's change colors again, and we're going to put 4 into the second derivative. I get a positive number. If it's positive, that means that I have a min, which affirms what the first derivative test told me. I still need a statement. So here comes my statement. So I would say, at a critical value of 1, the second derivative is negative. Therefore, function is concave down, which leads to a max. Okay, so that's your first value. Okay, so then do the second one. At critical value of 4, the second derivative is positive, therefore the function is concave up, and that leads to a minimum. Okay, now, I did these two tests and the accompanying statements for completion. You usually will not have to do two in a single problem. But wherever you are asked to do a max or a min, you must test for it. You just can't say that's the max. I want to see a sign chart and a statement. All right? And then make sure you answer the question, which would be to use your x value and actually get the y value that they are looking for. Okay, so that's example 1. On the next page, we'll do example 2. Okay, so in this problem, in example 2, they're asking us to find the maximum quantity. Okay, the maximum quantity is also going to be the y value or the q value in this situation. They give us a function, but this function is in two variables. That's a concern. And then they give us a constraint. So it says given x plus y equals 4. That is your constraint. So, a couple of vocab words. Okay, the objective function, so objective function is q equals xy. Okay, that's a new term for us. So the objective function gives us our job. We're going to use this function to answer the question at hand. Okay, the constraint we're going to use to modify the objective function. So your constraint is that x plus y equals 4. So I tend to do this little star so that I know that I'm adjusting the objective function. You can either switch out the x or the y. I'm going to switch out the y by saying y equals 4 minus x. Okay, so my objective function modified by the constraint equals x, that doesn't change, but now y is 4 minus x, and since it is not a monomial, it's a binomial, I'm going to put in parens because that x gets multiplied by both the 4 and the x. Okay, so let's go ahead and do that multiplication because it's going to make our problem easier. You could do it as a product rule, but why do that? So this is what I have for my new and improved objective function. After a while, we'll just stop doing the stars, but I'll just do it now just for consistency. Okay, so I'm going to find this derivative. And that's going to be 4 minus 2x, and that has to equal 0. Okay, so 4 plus 2x, 4 equals 2x, divide by 2, divide by 2, so x equals 2. In this situation, I only have one critical value. It is 2. But I'm going to test for it because I want to make sure that this particular critical value leads to a max. So on the next page, we will keep our work going. So let me just cut this out. So I'm going to cut this out. Maybe we'll even go up to here. Okay, so I'm going to copy that. We'll go to the next page and continue to work. Okay, so let me just put this. I think I'll just do that. Okay, that looks good. Okay, done. Okay, so now what I'm going to do is I'm going to test it by doing my table. Here I only have one value. That value is 2. This is going to be my f prime of x. I test to the left of 2, so let's pick 1. I'm going to change colors again. When I pick 1, I'm going to put 1 in here. 4 minus 2 is a positive number, so this is a positive here. Now we'll test on the other side. If I pick a number to the right of 2, let's pick 3. 4 minus 6 is negative, so this is negative. So what does my function look like? Well, it's positive here and negative here, so I can say in my statement, at the critical value of 2, the slope changes from positive 2 negative, and therefore we have a max. Okay, so they want to know what is the y value. Excuse me, they don't want to know that. They want to know what is the maximum value. So I need to figure out what the q is. So let's look back for a second and let's look at our objective function. So here it is. It is q equals xy. So I'm going to take that and copy it, and we're going to go 2 pages over, and I'm going to paste it here. Paste. Okay, so now that's my objective function. What did I just find out? If we go back a page, what did I just find out? I found out that x is 2, and that will give me a max. So let's cut this out as well. So I know x is 2. Go back. Oops, let me do that again. I know x is 2. Okay, I have that. Copy and paste. Okay, so I've got those 2 pieces in there. Okay, now let's go back one more time because I want to find my constraint. And there it is. Okay, x plus y is going to equal 4, so y equals 4 minus x. So I'm going to take both of these, and let's take this, and we're going to copy that, and then we're going to go to our last page here. Okay, and paste it. Okay, so let me move this down here. So we've got these little pieces. They want to find the maximum q. Okay, so since q equals x times y, so far I know that x is going to be 4 for a max, but I don't know what my y value is. So let's come up here and we'll solve for y. Okay, here's y. Y equals 4 minus x. Oh, I'm so sorry, x is 2. If x is 2, so I'll change that in just a second, then y is also 2. So let me go and erase that. Maybe we'll keep everything in red. So q is going to equal the 2 I got up here, right? Up here I got the 2. I have a y that's 2. So q will equal 4, and that is my q max. That is my answer. All right, so did I answer the question? They wanted me to find out the maximum q given the objective function, that was the objective function, and the constraint. Okay, so I had this objective function right here and the constraint right here, and I used it to do a maximization problem, which was just take the derivative, set it equal to 0, and evaluate the critical value. I got my x by doing that. Okay, that I got directly. Then I got my y indirectly by plugging my x back into my constraint. And that's giving me a q max of 4. So that is day 1. And for homework, you're going to do the day 1 packet problems, which actually were from the textbook. They're page 186, numbers 1 to 10, but I did write them up for you so you can do it by looking at my sheet. But do it on loose leaf so that you have space to work it out and make sure you are answering the question. So that's it for the 2.5 day 1.